Titanium dioxide nanoparticles, text TiO_2, text NPs, are particles of titanium dioxide, text TiO_2, with a diameter of less than 100 nanometers, nanometer. Their nanoscale size gives them unique physical, chemical, and optical properties that differ significantly from their bulk material, making them useful in a wide array of applications. Key properties. Text TiO_2, text NPs, primarily exist in three crystalline forms, or polymorphs, which affect their properties: anatase, rutile, and brookite. Photocatalytic activity. This is one of their most significant properties. When exposed to ultraviolet, UV, light, text TiO_2, text NPs, generate highly reactive oxygen species, ROS. This property is strongest in the anatase phase and allows them to break down organic pollutants and kill microorganisms. UV absorption. They exhibit strong absorption of both UVA and UVB radiation. High refractive index. This property is responsible for the opacity and whiteness of bulk, text TiO_2, but at the nanoscale, the particles become transparent on the skin while still blocking UV light. This property is particularly strong in the rutile phase. Stability. They have low production costs, and high mechanical, chemical, and thermal stability. Major applications. Text TiO_2, text NPs, are one of the most widely produced nanomaterials, found in numerous consumer and industrial products. Application area. Specific uses. Property leveraged. Cosmetics and personal care. Sunscreens, UV filter, toothpastes, shaving creams. Strong UV absorption, transparency on skin, rutile phase. Environmental. Water purification, air purification, self-cleaning surfaces, anti-fogging coatings. Photocatalytic activity, decomposition of pollutants and microorganisms. Materials and pigments. White pigment in paints, plastics, paper, and food products. High refractive index, whiteness, opacity, larger size, text TiO_2 used as pigment. Nanoparticles in plastics, coatings. Energy. Dye-sensitized solar cells, DSSCs, hydrogen fuel generation. Photocatalytic activity, superior electron mobility, anatase phase. Biomedicine. Photodynamic therapy, PDT, for cancer treatment, antibacterial agents, drug delivery systems, medical implant coatings. Photocatalytic generation of ROS, for cell death, biocompatibility. And environmental concerns. The widespread use of text TiO_2, text NPs, has raised concerns regarding their potential effects on health and the environment. Human health. Toxicity. The toxicity of text TiO_2, text NPs, is primarily attributed to their small size and the generation of reactive oxygen species, ROS, which can induce oxidative stress, inflammation, and genotoxicity, DNA damage. Routes of exposure. The main routes of human exposure are inhalation, a major concern in occupational settings, and ingestion, from food additives or general exposure, as well as dermal exposure, from cosmetics, though absorption through intact skin is generally considered very low for larger nanoparticles. Organ accumulation. Inhalation or ingestion can lead to accumulation in organs such as the lungs, liver, kidneys, and spleen, potentially causing organ dysfunction. The International Agency for Research on Cancer, IARC, classifies bulk text TiO_2 dust as possibly carcinogenic to humans, Group 2B, based on inhalation studies in animals, though the link to human cancer is controversial and depends on particle size and exposure dose. Environmental impact. Aquatic ecosystems. Text TiO_2, text NPs, can wash off products, like sunscreens, into water bodies, where they have shown toxic effects on aquatic life, including algae, inhibited growth, disrupting the food chain, fish, gill damage, and invertebrates. Bioaccumulation. There is concern about the potential for these persistent nanoparticles to bioaccumulate in organisms and move up the food chain. Soil. Release into the soil can negatively impact the proliferation and survival of soil invertebrates.